Hi, everybody. It's Miss Austin, and I'm going to be going over the Unit 2, Lesson 2 practice problems that were assigned for today's homework. And we're doing 1 through 4. So the first one says line SD is a line of symmetry for figure AX PDZHMS. That's a mouthful. Okay. And Noah says that AX PDS is congruent to HM ZDS because these two sides are corresponding, right? This figure is congruent to this figure. Why is Noah's congruent statement incorrect? Well, let's just look at the way he says it, right? Once you know which shape is congruent to the other, the order is important. So if I look here, he did A, X, P, D, S. So A, if I look over here, which point corresponds to A? M. So I need to go in the same order. Once he starts with that one, if he starts here, then I need to start here. So it should have been M, then H, Z, D, S. So he reversed the H and the M. H does not correspond to A. M corresponds to A. Okay, so why is his statement incorrect? I would say A is not corresponding to H, and that's what he did. He said A was the first one, so H. So now let's say it correctly. It says write a correct congruent statement for the pentagons. So I'm going to keep the first one the way he had it. A, X, P, D, S, right? A, X, P, D, S. I want to go in that order is congruent to, I need to start here. M, H, Z, D, S is congruent to M, H, Z, D, S. So the only thing he had wrong was he had the first two letters. And yes, these two sides are the same. They're congruent and they do correspond to each other, but you have to say it in the correct order. All right, number 2. It says figure MBJKGH is the image of figure AFEKJB after being rotated 90 degrees counterclockwise about point K. So I did this. I just want you to see it. I got some parchment paper out of my kitchen drawer, right? So here's that shape, and it said it was rotated counterclockwise 90 degrees. So look at this. I'm going to rotate this. Oh, wait a sec. Counterclockwise. Okay, this way. Boom. So do you see how that original shape, after a rotation around this point, 90 degrees counterclockwise, became this shape down here? Okay, it says draw a segment in this one to make a quadrilateral. So right now, I'm just going to show you this one. Okay, this is not a quadrilateral. This is a 1, 2, 3, 4, wait, 1, 2, 3, 4, 5, 6-sided shape. I need to draw in something to make it a 4-sided shape. I'm going to draw in this one right here. Does everybody see now that I've created? I'm going to shade it in. I just created a quadrilateral, okay? And it says, write a congruent statement for the quadrilateral you created in the original and the new one. Okay, so let's look at this. So if I go like this, and I rotate this, then I need to draw the line in the new one from here to here. So that would be from J to H, right? So now I have this one, which corresponds and is congruent to this one. Now this is just one example. You could do something else. So now I have quadrilateral, and does it matter what letter you start with? Absolutely not. I'm going to start with the letter A, and I'm going to go this way. So I know that this quadrilateral, A, F, E, B, that's this one that I shaded in right here, is congruent to, I got to say it the same way. So A, look, I said A first, I got to say the point that corresponds to A, which is M. And then I went this way. I went A, F, E, B. So I have to go M, B, J, H. M, B, J, H. And I probably could have created a different quadrilateral too, right? That's just the one I created. All right, that was number 2. Number 3. Triangle HEF is the image of triangle FGH after a 180-degree rotation about point K. So once again, I wanted to show you this. Let me get it. Here's FGH. And it says HEF is the image. That means it's the new one. So I'm going to take this. I'm going to put my pencil. It says it rotated about point K. Now 180, it doesn't matter if you go clockwise or counterclockwise. So maybe keep your eyeballs on point F, okay? F becomes H. G becomes that top one, which is E. And H becomes F. And you can tell by the way they're written. Look, HEF, FGH. Those letters tell you everything. And because that's maps, right? That's a 180-degree rotation. They're congruent because that was mapped onto that by a rotation. That's the definition of congruence. Okay, so now just based on the way the letters are written, I'll be able to figure things out. So we're supposed to select all that apply. So let's try this. It says triangle FGH is congruent to triangle FEH. Okay, look, if they say FGH, then I got to go over here and go in the exact same order. F does not, F is supposed to be with H, right? F goes to H. The letters tell you everything. If they're going to say FGH, FGH, then I would have to go in the same order. I would have to say HEF. That's not the way they said it. And if you look closely, you can tell that this segment is not the same length as that segment. That one is not correct. Okay, next one, it says triangle EFH. So they go EFH is congruent to GFH. So they went from the first to the last, or sorry, the middle to the last to the first. They went EFH. So if that was true, they would need to go GHF. Is that what they did? No, they did GFH. It's not the right order. And you could look at the figure. EFH, is that the same as GFH? No, it need to be reversed, GHF. Angle KHE, I'm going to mark it, is congruent to angle KFG. When I rotated it, this side went to this side. Yes. Angle GHK is congruent to KHE. No, because when I rotated it, right, this angle goes over to this side. Watch it. That angle is over there now. No, not true. Segment EH is congruent to FG. Now this you could look at your congruent statement as well. Look, EH, that goes the middle to the first, is congruent to FG. Yes. Now they didn't say those in the right order, but if I'm just talking about the segment, it's okay. EH is the same as this one over here. Yeah, that when it rotated went over to that one. If you're talking about the whole polygon, whatever it is, you need to say all the points in the right order. But if you're just talking about the segment, you can say FG or GH. All right, last one. Segment GH is congruent to EF. Segment GH, that's this one, is congruent to EF, right? Hopefully you can visualize when I rotated at 180, that one landed right there. You could also look at the letters. It says GH, that's these two, is congruent to EF. That's those two. Yes. C, E, and F. All right, last one. When triangle ABC is reflected across line AB. So see how I'm going to reflect it across that line. And the image is ABD. Why are segment AD and AC congruent? Why? Congruent parts of congruent figures are corresponding. Well, they're asking why they are congruent. We don't even know they're congruent yet. I don't know. Corresponding parts of congruent figures are congruent. Okay, so after a reflection across this, right, that mapped triangle 1 onto triangle 2, which guarantees they are congruent. And if two figures are congruent, then all the parts of this one that got mapped onto that one are congruent, and those two sides are corresponding. Corresponding parts of congruent figures are congruent. We can just go through the last two, but we kind of know that's it because it didn't say select all. An isosceles triangle has a pair of congruent sides. Who said this was isosceles? Got no idea. Okay. Segment AB is a perpendicular bisector of DC. Could be, but we don't know. Okay, the only one guaranteed, corresponding parts of congruent figures are congruent. I hope that was helpful. If you still have questions, please ask next time we have class. Have a great day.